and visiting from Montana State University here at New Mexico State in Las Cruces to do isotope geochemistry in Dr. Frank Ramos' lab. We'll be analyzing andesites and daceites from the central volcanic zone in the Andes. Okay, so what we're doing here is weighing out 200 milligrams of our powdered sample and putting it in a labeled Teflon beaker, this, in order to prepare our samples to be digested. So this is a hot plate when we need to evaporate out all the acid in a sample and dry it down. We put everything on here. So right now I'm drying down the lead wash so that the volume of acid is small enough to pour into a new beaker. We have our dissolved samples ready to run through the lead columns, but first we put them in these little centrifuge tubes and put them in the centrifuge. So now we're going to load the sample into the cation exchange columns, and we just take a half milliliter pipette and we clean it off. And we're just going to load it down into the column and be careful not to touch any of the sides of the column on the way down to reduce any contamination that we might have. We're about to backwash the cation exchange columns, and we do that by sucking up the resin in the columns with this pipette. And we have to take all the resin out because if you were to just put water through, it would expand the resin so much that the column would burst. And so we put water in it and suck it up and place it back in and allow the resin to settle.
The standard in.
Okay. You can run it more than once?
If it lasts long.
Okay.
And now that I have the defocus working,
we put them into a turret and load them here, and we run a current through them which ionizes the atoms, right now which is strontium, and pushes them away and accelerates them, and this magnet accelerates different masses at different speeds. So you have a deflection of different masses of isotopes. Figure out what our strontium ratios are, or neodymium. So you can see the voltage here and here, and then everything's run by this DOS system computer.